Hello, everyone. My name is Jerome Stuenenberg. I'm the co-founder of a Geneva-based company which is called Genève Net Systems. We are open source infrastructure specialists. So we do everything that is enterprise infrastructure, but only based on open source components. So that means virtualization, cloud, monitoring, things like Puppet, all these kinds of tools. So we are the organizers of the Genève Open-Source Meetup group, which is here if you want to sign up. Before we start, I'd just like to thank Blue Infinity for hosting us, and also thank you to the Elastic user group for inviting me. So the project I'm going to talk about tonight is the origins of the project is actually a customer request. The customer came to us and said, we want to know everything that happens on our Unix servers. So the translation for that is our auditors want us to know who did what, when, and where, even for root super users, super admin users. The customer actually doesn't care, but it's the auditors that that want this to happen. So we had a look at the different possibilities. So I'm talking about Linux servers here. I'm not talking about Windows environments. It's mainly Linux. So we had a look at the different solutions. The first solution is to lock the SU program, okay? And instead of that, use sudo with logging. So in that, what happens is that you force the users to use sudo to become root, and then whatever they do is being logged. The drawbacks of this solution is that anyone who is a little bit skilled can sudo into a program, into a shell, into a program and spawn a shell, and then they're just invisible and they can do whatever they want on their Unix box. So that's the drawback. The solution 2 is to use something which is being used a lot at our customers these days. It's called an SSH bastion. For example, is Wallix or Balabit, if you've heard of that. These programs, what they do is they're like a gateway, and the users have to go through that gateway to go to the servers. And that gateway then records all the sessions. So the drawbacks of that is that you introduce a single point of failure into your architecture because of that gateway. And it's pretty complex to set up, and it has a high cost, at least with Wallix and Balabit. Depending on the licensing scheme that you use, it can become really expensive. The solution 3 is to use a keylogger. This is pretty easy to do, actually, and everything that the user types on the keyboard or in a terminal gets logged into a log file. So the problem with that is, the first one is that it logs passwords also, and you don't want to have passwords in a log file. That just doesn't work. And it's very difficult to search. So if you want to know what happened at a specific date, you have a string of letters, and it's just impossible to do something really useful with it. So then you have other tricks, such as, for example, using the prompt command environment variable, and then in there you write something that logs all the commands. But the drawbacks is that it's very easily circumvented by the user, so that's not a secure solution either. So what we've come up with was this solution. It's to use the audit daemon, and then the elasticsearch stack to store all the commands. So how does that work? So I just want to make a quick presentation of how audit works. Okay, that's important to understand the solution. So audit is it's a user space daemon here and a kernel module. And how it works is that whatever happens on the machine is sent by the kernel to the audit daemon here. And the audit daemon has a set of rules that the super user writes. And these rules tell audit what to log and what not to log. Okay. So when audit encounters an event that it has to log, it does two things. It sends it to the file which is called /var/log/audit/audit.log, and it sends the event to another daemon which is called the audit dispatcher. And then when you have all your logs in here, you can use tools such as AU report and AU search to actually go through the logs and analyze that and find whatever you're interested in. So we're going to use the dispatcher here. So what we do, now before I show you the solution, just an example of an audit configuration. This is a set of audit rules. In here you say first delete all the previous rules, then set some technical stuff. Then tell audit to make the configuration immutable. What this means is that if you activate this, then a reboot is required to change the audit rules. So that means that even the super user cannot change the audit rules. So even he cannot change it temporarily to hide himself and then change the rules back. That's not possible. Then we tell audit log all changes to local time. So okay, it's a bit complicated. I'm not going to explain everything, but basically what we say is that whenever we call the system calls to set the time or to change the clock, or if we write to etc local time, which is the file where we store the time zone, then we log an audit event. Here we say to audit log an event whenever there is a modification to etc group or etc password or one of those other files. So this is how audit works. So what we are interested in here, in our case, is these two configuration rules. These two configuration rules, they tell audit to log an event whenever the system calls the exec VE system call. The exec VE system call is the system call that gets called whenever a process creates another process, whenever there's a process fork. Okay, so whenever there is the execution of a new process, these two rules make sure that that will be logged. Okay. So let me give you an example. Let's say the user types the command ls-la. Audit what it will do with, because of those two rules that I showed you before, it will log this. This is extremely complicated and completely useless. I mean, you can't get anything from this. So what we do is we configure the audit dispatcher to send all this to a plugin, and this plugin is called AU-DispSimplify. This is a simple program that's available on the internet. It's open source, and it's at this address here. And what this plugin does is it takes all this complicated stuff here and rewrites it in one line. Okay, here you have two lines because it's not wide enough, but it's actually one line. And you can find here all the details about this command. So you can find, for example, the ID of the audit event, the time at which it occurred, the host name on which it occurred, the process ID, the executable, the user that executed this process, the original user that executed this process, and the actual command with the arguments. So this plugin dumps all this into a file called /var/log/AU-DispSimplify. And as you can see here, you have something which is very easily parsed by elasticsearch because it's key value pairs. Okay. So what we do is, once we have this, we send this to Beats, and then to Logstash, and then to Elasticsearch, and then we use Kibana to analyze all this. So example configuration of FileBeat here. It's pretty simple. We tell Beats to read the varlog AU-DispSimplify file, and then we tell Beats to send all this to Logstash, which is here running on localhost. Then in Logstash, you will recognize a simple Logstash config file. We specify an input here so that it gets inputs from beats. Then we send the data through a first filter, a grok filter, to match the event log line. So this will generate. Where are they? Keys that are called audit ID, host, TTY, name, etc., etc. And then, of course, we send the time through the date filter in order to convert the string into a real date. And then we output all this to Elasticsearch, which is also running on localhost. So let me give you a little demo. So I'm going to log onto the machine here. I'm going to do things like ls, who am I, date, ls, etc., etc. And then I'm going to do a sudo -s. And here I'm going to do an auto refresh of 5 seconds so that you can see what happens. And here in Kibana, we're going to, so here you get everything that comes from Logstash. But we're only going to show what's really interesting here, and that's the popular fields here, which are host, org user, user, and command. So here you see that I've logged on. I did an ls. Then I did a who am I, a date, an ls again. And then I did a sudo. And then here as root, I can do something like that, of course, is not going to work because I'm not connected. But okay. So I'm going to do ls a few times because there's a lot of bufferization. So if I want to show it on Kibana, I have to do a little bit of execute a few commands. And so here, oh, not that much, not that much. So here you can see that after the sudo, the user here is now root, but the original user is still CleverNet. And so, yeah, of course. Up. So here you can see the yum remove htop, yum install htop, the ls, etc., etc. So if I do something like this, I added the etc password file, for example. Up. The dispatcher does a lot of buffering because it has to analyze multiple lines. So it waits until it's sure that it has all the lines pertaining to one single audit event. So that's why there's a lot of buffering. But I mean, in the end, it's you get everything everything that happened. So here you can see the vi etc password. So this will allow you to do things such as yum install here. And let me take away this. And so let's say I have a server and something has been installed on that server and I don't know what something changed, you know. I can search for yum install and then I can see that hey, John something did a yum install of this particular package on this machine at this time. And now you get a real log of everything that happened on your service. If you look for this, for example, you can see who touched the etc password file. So of course you do something like this if oops, if you have multiple hosts, because in this case here in the demo there's only one host, but if you had like 20 or 30 or 200 hosts and you want to know exactly what one person did on a particular host, you could do a query like this, for example, and then you can see what that person did. So this is it's pretty nice because you can, when you have multiple hosts, you can actually see the users jump from one host to the other, you know, because it's arranged by time, so you see it when one user jumps from one host to another one. That's pretty nice. So this is a solution that that runs in production in a Geneva-based private bank today. So it's not just a pocket; it's a real solution that has been put in place. And what I want to say with this this demo also is that Elasticsearch is not only a central logging tool. You can use Elasticsearch also on the application level. So here it's still logs, but you can see that you can log whatever you want. Okay, so you can go anywhere from the system to the application. So the solution works fine, but there's always a drawback, like in every solution. And here the drawback is that here you have everything that is executed on the machine is logged, like everything. Okay, so every process that starts is logged. So if you have a cron job, for example, that runs, you will get all the things that the cron job does, you will get them in here. So in order to prevent that, what we do is there is a config file of the plugin that simplifies the data, and this config file will allow you to ignore certain things. So for example, if you have Nagios running on this server, Nagios will execute many processes. So what you want to do is, you want to say, I want to ignore every event that is created by the user Nagios. Or I want, if you have a Nagios probe on this server that sends passive events to a Nagios server, then you can say, I want to ignore every log event that is sent by this program. And the one thing which is really interesting here is the TTY equals non-config config item, and that says basically that you don't want to log events that are generated by processes that don't have a TTY. Okay, so what happens is that you really get only the things that are actually executed from a terminal. Okay, and this will prevent you to have a lot of garbage in your Kibana here.